Now let us see refraction at the spherical surface. So to discuss this concept, we should take a spherical surface, and in the beginning I told you the a medium which consists of a spherical surface is called as a lens. Lens means it is optical medium bounded by two spherical surfaces. But there is a one condition that at least one of their surface should be spherical. Another one can be planar. So in this situation, we will take only one surface, spherical surface, and we will try to get an equation for that. Yes. Let's see. Now let us draw a spherical surface. See, this is one spherical surface. Another one is a plain surface, and it is a transparent medium, and which is made from glass. So now this air has a refractive index N1. This is the glass medium which have the refractive index N2. We should draw an axis which joins the center of curvature and the optic center. So since it is contained only one surface, we can draw the center curvature over there. Center curvature C. Now let us take an object. Let's say object is placed at this point. O is an object. Let us name this surface as MM. MM is a surface. And let's incident a ray of light, or there is a ray of light coming from this object. And this object is placed at a distance of U from the optic center. U is the distance which is optic center from the optic center. See from here, U is the object distance. There is a ray from this object will fall on this. It will fall on that spherical surface. It will fall at this point. At the point of incidence, we should draw a normal. We have to draw the normal. We are drawing the normal, and that normal always passes through the center of curvature. See, okay? This is a normal we have drawn at the point of incidence, and that normal drawn should pass through the center of curvature. Now, this ray will make an angle I here. It is the angle of incidence. So this angle between the normal and the incidentary direction. This is the direction of incidentary. And after refraction, here the medium changes. Since the medium is changing, it will undergo refraction. So the ray will bend. And it forms an image over. They will bend over there. After bending, it will converge. It will meet the principal focus at one point where we will get image. That's why I'll write that as a P. So the distance from this optic center to the image form can be called as image distance. It is a V. And the distance from M to C can be written as R. It is the center curvature, right? That's why it is also called as radius of curvature. This is what we got here, and this is what we understood from this. So this is a situation here. Okay. Now see here. So this is the angle of refraction. This is a normal. This is the refracted ray. So angle between normal and the refracted ray is called angle of refraction. So this is now we have to do some mathematical calculations here. So we need to prove an equation for this. We need to know the relation between the refractive index of the medium as well as object distance as well as the image distance. So this is what we should get here. So to prove this, we will consider some triangles. So I should name the point of incidence. This point, let me call this point as a M. This is a point. Now, let us take the triangles. We are doing the mathematical calculations, that's all. So, the triangles are MOM, one triangle, MCM, second triangle, MIM, that is the third triangle. So, the surface we have considered is a spherical one here. But in the beginning itself, I told you, we are considering a infinitesimal part of a spherical surface. Infinitesimal part means it is a very small part of a spherical surface. So if you consider a very small part of a sphere, then that part will look like a plane. So you should imagine that if this is an infinitesimal part of a sphere, then this will look like a plane. So the MM will be a straight line, but in the figure it looks like a curved one. But you should imagine that it is a very small part of a spherical surface which is planar. Yeah. So the three triangles MOM, NCM, MI. From figure, in triangles, which are the three triangles, MOM, triangle NCM, and third one is triangle MIM. In these triangles, let us write tan theta. Okay, let us write tan of this. Let us write the tan of these angles. Tan of MOM. Tan of this angle, tan of this angle, tan of this angle. Angle found in this triangles are at the point O, at the C, and at the I. So if you apply the tan of that, tan of MOM equal to, tan is equal to opposite by adjacent. This is opposite, this is the opposite. NM, adjacent is MO. You should write MN and MO. Because you should start measure the distance from optic center. That's why. Tan MOM, and here I am writing tan of second one, which is NCM, which is equal to, I'll leave the space here, something I have to write, I'll write that later. Tan of NCM, where is it? NCM is equal to opposite by adjacent. MM divided by MC. Mn divided by MC. Let us write the third one. Tan of NIM. Tan of NIM, which is equal to MIM, which is equal to MN divided by M. Mn divided by Mn divided by M. So these are the three trigonometric equations we wrote here in terms of tan. Now I told you we have considered infinitesimal part of the spherical surface. That's why angle formed, whatever the angle formed, will be very small. Okay, if you consider planar surface, then the angle formed with the ray of light will be very small. So for a small angles, tan of NOM also equal to NOM itself, and tan of NCM is equal to the NCM itself, and tan of NIM equal to the NIM itself, because taking the tan of the quantity will approximately equal to the that angle itself. When the angles are too small, then we can write that angle equal to something value. So here I am writing the same tan of MOM, which is approximately equal to NOM, and here approximately equal to NCM, here approximately equal to NIM. You should write for small angles. In figure for small angles, in triangle MOM and see NIM, you can write tan of this is equal to MOM, this is equal to MN by MO, MN by MC, MN by MI. Now let's see this. So let us consider a triangle. Here the triangle should consider is MOC. Now we are considering the triangle MOC. So in this triangle, there is an angle I which is outside this triangle. So this angle can be called as an exterior angle to this. Okay? So there is a formula which is used in the triangles. That formula is exterior angle is equal to the sum of the interior angle. We will use that technique for getting the solution in this derivation. So the exterior angle, outer angle, which should be equal to sum of the interior angles. These are the two interior angles. So its sum must be equal to the sum of this. Yes. That's right. In triangle MOC, exterior angle equal to sum of interior angle. Exterior angle is equal to the sum of the interior angles. What is exterior angle? That is I here. I is the external one. What are the interior angles? M, O, M you can write, or you can write M, O, C. Okay, both are same. Because however you written, angle formed is at the O. If you said MOM or if you said MOC, then the angles formed at the O itself. That's why writing the M and C doesn't make any kind of a difference. That's why I will write MOM plus NCM angle NCM. So let us substitute the value because we know that MOM is equal to MN by M. So MN by M, correct. MN by MO plus NCM. NCM is equal to Mn divided by MC. Mn divided by MC. So this is the equation for angle of incidence. In a similar way, let us try to find the value of this angle. That is angle of refraction. So to find the angle of refraction, we should consider this triangle. See, CNI or CIN. We should consider this triangle. We have to consider this triangle. See, that is the triangle we should consider. Initially, we have considered this. See, this is the first triangle we have considered. Then the second triangle to be considered here is this one. That is CN. In this is an angle R, and to this triangle, exterior angle is formed at C. Here, an exterior angle will be formed. That's why, according to this formula, what we can write is exterior equal to sum of interior angles. So this this is MCN is equal to CNI plus NIC. I hope you understood. Exterior angle is this one. NCM you can write. NCM equal to CNI plus NIC or NIM. Both you can write. Similarly, what you can write is NCM, okay? NCM equal to sum of the interior angles, that is R plus NIM or NIC. They are all the same. I told you. NIM. Why I am writing NIM? Because I know the value for NIM. That's why I am writing M instead of CM. And it doesn't make any difference because the angle is forming at I. So R is equal to NCM minus NIM. NCM minus NIM. So let's write this is the equation number 1. Let us substitute the value for R. If you substitute the value for R, you will get R is equal to NCM, Mn by MC, and NIM is equal to Mn by Mi, So this is a equation for angle of refraction. Then for the refraction we can apply Snell's law. For Snell's law it can be applied. Applying Snell's law for small angles. I told you angles formed are very small. For small angles, you can write N1I equal to N2R. We know that N2 by N1 is equal to sin I by sin R. If you multiply this, N1 sin I is equal to N2 sin I. N1 into I, N2 into R. If the angles are very small, then you can write sin I is equal to I itself, sin R equal to R itself. That's why I have written N1 into I into N2 into R. Let us substitute the value for this. N1 into I equal to Mn by Mo, Mn divided by Mo plus Mn divided by MC, Mn divided by MC is equal to N2 times R equal to Mn by MC minus Mn by M. So these are the equations we got here. from 1 and 2 we have written like this. So m1 into, see here, you can take the mn common here. You can also take the mn common here, and if you multiply or if you divided m1 on both sides, these mn will be cancelled because it is on both sides. If you cancel the mn on both sides, it doesn't make any difference to this equation. So we'll remove this, and after that we have to multiply this with the each terms, whichever inside the bracket. So n1 into this one, n1 divided by mo plus n1 into mc, n1 into mc is equal to, if you multiply this, n2 into mc, if you multiply to this, minus n2 into m1. Now let us MCs are there. Let us write this together and let us take this to this point so that we can write n1 divided by mo. Take this take this term so that you can write plus n2 by mi, which is equal to n2 by mc. n2 by mc. Take this term because the denominator is the same. That's why take the m1 by mc to the RHS. It becomes plus is there. It becomes a minus n1 divided by mc. So you can directly write this as n2 minus n1 divided by mc. Have you got this? Now we have to apply the sign conventions. We should apply the substitute the value for these terms, and we should apply sign conventions. Substituting values and applying sign conventions. You should apply the sign convention as well as substitute the values. We get mo. Let us substitute the value for mo. Let us look at the diagram. Mo. Distance is u, and according to the sign convention, direction is this. You are measuring like this. That's why minus. Then mi, second thing is mi is equal to mi, which is we will measure along this direction, which is the same as the direction of this incident, refracted ray. That's why it is a plus v. Third one is m2c is r, and it is plus r. Now let us substitute here. n1 divided by mo, which is minus u, n2 divided by mi is plus u. That's why I will write second term as a first term, n2 by v minus n1 by u, and here it is a positive, but I here write it a negative, which is sign of the u, minus n1 by u, which is equal to n2 minus n1 by mc. mc is equal to. So this is the formula which relates the refractive index of the medium and objective distance, image distance, and the radius curvature of the respective surface. So in this equation, see, this is the image distance, this is the object distance, this is the radius curvature, as well as we have refractive index of the two mediums. So this is the equation for spherical when a ray undergoes the refraction to a spherical surface.